Okay, everybody, this is chapter 9, section 2. This is called reflection. This is once again, we're going to be moving a figure, typically on a graph, but we're going to start with just kind of some pictures and look at what reflection really means. And you guys actually, you've heard this term before when we were talking about back in the first semester, triangles being the same through angle, side, side, angle, side, those things. And that's because sometimes we had a triangle, two triangles drawn together and they shared a side. That side was reflexive, okay? So this is similar to that, but we're going to create the sign, okay? Or the side that's reflective or whatever, okay? So in this first, this first set of notes, I don't need you to write that down. This is really the kind of scientific part of it, if you really want to say that, how reflection is actually done. And to do this, I would need a compass and a protractor, being able to draw angles, being able to find a right angle, being able to get a line that's bisected and measuring it. So there's a lot that you can do using some tools to be able to do that. We're just kind of going to stick with kind of what the definition is and be able to find a point or a line or something on a graph that is going to be my line of reflection, okay? So we also all heard this term too, line of symmetry, okay? So it's making things that are equal to each other. So a line of symmetry is what we're going to use. So if you could put this definition down, it's a line over which a shape is reflected. And a shape could be a point. It could be, you know, we did a triangle with translations last section. It could be any kind of figure, okay? But we are still going to kind of use a graph to do most of this, okay? So if you draw these three pictures, I know that middle one's going to be kind of tough, but just kind of looking at this and draw these. A line of symmetry is going to cut something in equal halves, which, you know, it's like kind of like doing some origami here. We're going to fold the figure over this whatever line that we've created, and it's going to map onto itself. There's not going to be any kind of little parts that aren't matching up something with something else. We can fold it on that line and be able to match it up, okay? So using A, which is a hexagon, can I draw a line through it on which I could fold it in half, basically, and it would map onto itself, okay? So a lot of us, and when we've done this before, we found out that if you draw a line straight through the middle here, that's straight through the middle, I should be able to fold it on that line, and, you know, this point right here would map onto that point, this point maps onto this point, and that point would map onto that point, okay? And then these sides would all be matched up here, here, and then here, here, and so forth. Okay, so that's what a reflection is, or a line of symmetry in this case. All right, now is that the only one? Well, I believe if I took and folded it along this line, okay, it would map onto itself. So that means that this point and this point would map onto itself. This line and this line maps onto itself, and then so on around the line, okay? So that's what a line of symmetry would be. Now, in the past, when I've used this before, some students think that, you know, I could go ahead and do it diagonally too, but if you really can try to visualize that, that's not going to map onto itself, okay? It's not going to come out to be equal on all the sides, so it's going to be kind of off-centered, okay? So that one's not going to work, okay? This middle one, section B with this heart and a doctor, it looks like, or physician in the middle of it. It looks like, hey, if I cut it right down the middle here, it would map onto itself. But unfortunately, doctors sometimes have these pocket protectors, and I would not get the same image on both sides. So that one would have 0, okay? If that wasn't there, then I have at least 1, okay? All right, the This next one, a flower petal or just a flower bud. To me, it looks like I'm not really sure if that one would have one, but if I just kind of look right here, if I drew a line through here right like that and folded it, would it map onto itself? And if you can visualize that, it will. Okay. And if I continue around, I think if I drew one through here, that would map onto itself. And you could go all the way around, I believe, through each one of these petals and be able to do that. Okay. So that one looks like to me that's 5. So 5 lines of symmetry. Okay. All right. So there you go on that one. So if you go ahead and draw this graph, and then if you could write down these 3 different examples here, and then we'll kind of go through them one at a time. I am going to change this one though. I'm going to say y equals 2. Okay. So if you could do that really quick. Once again, you can hit pause, draw it out, and come back and hit play, because I'm going to start with the solution right now. Okay. All right. First off, what all this means is when you see a capital R, it stands for the word reflection. Okay. So we use that to say, hey, you're going to go and reflect something. Now remember, you reflect something across a particular line. So graphs obviously have lots of lines. So I have to tell you which line. So, and this is kind of called a subscript. So it's kind of written smaller at the bottom of the R. So I want to reflect something across the x-axis. So here is the x-axis. So I'm going to draw my line for that one. All right. And I'm going to reflect a specific point. So they have to give me a point or a figure. It could be like a triangle or something like that. But I'm going to just reflect a point right now. Okay. So I'm going to plot that point 2, 2. We'll call it H. And I want to reflect it across the x-axis. Now, if you remember back in section 1, for these kinds of transformations, you have to keep distance and angles the same. You have to keep this a rigid motion. Well, this is just a point, so keeping a point rigid is pretty easy. But if I'm going to reflect it, I have to keep distance. So how far is that point from the x-axis? And if we count squares, it's 2. So that means I have to put it on the other side of the x-axis, keeping the same distance. That means I got to be 2 away. So I believe that's going to put me right here. Okay. And I'll call this one H prime, because this was my H was my pre-image. H prime is where I moved it to. That becomes my image. Okay. So I kept the same distance, just counting squares. Has to go on the other side of that line, same distance. Okay. All right, let's go to B. I changed this again. Capital R once again is reflection, but I said y equals 2. Now this is where you have to be smart and understand what graphs do. Y equals 2. Well, y equals 2 right here, but it needs to be a line. Well, where's the line? Okay. But if you think about it, if I was graphing points and I had y as positive 2 and a bunch of different x's, my line would be all along here. Okay? So that y equals 2 is my line. Okay? So you've got to be good at that. That's more what we're going to use. We're not really going to use an axis all the time. We'll say y equals this or x equals that. We got to know where that is. Okay? The point they give me is 5, 4. So there's G. Okay. And once again, I'm going to keep distance. Okay. So I'm looking that this point is, once again, it's 2 away. It's not always going to be 2 away. Okay. So just be careful with that. It's 2 away. So I got to go 2 to the other side. So I get here. and that's going to be G prime. And we sometimes like to, I forgot to do this on the previous one, label the point. So that's it, 5, 0. Okay. This one right here, the first one we did, is at 2, negative 2. Okay. All right. Okay, this last one, we're going to, capital R means, once again, we're reflecting it. We're reflecting across x equals negative 1. So we got to find where is x negative 1. It's right here. But where else does x equal negative 1? So if we're, good about how to graph things, x is negative 1 at every point along here. Y is changing, but x doesn't. So there is x equals negative 1. Okay. The point they give me is 1, 0. And that's J. Okay. And so I want to reflect J across x equals negative 1. So, unfortunately, it's the same thing here. I'm 1, 2 away, so I got to go 2 away to the other side. I get that. I'll call it J prime. Okay. And that point is at negative 3, 0. Okay. Now, just really quick, you don't have to take notes on this or anything, but I'm going to just kind of go back and show you why I changed this, because it's a good thing to know, but I just felt like it wasn't really appropriate for what we're doing. If it was y equals 4, like I said, don't write this down because I'm going to erase it. Y equals 4 is this line right here, okay? And they gave me a point 5, 4. Well, 5, 4 is right there. So it ends up being on the line. Well, how do I reflect that? Remember, I got to reflect it across that line, and I got to keep distance. Well, it's on the line, so it can't really reflect, can it? So it really reflects upon itself. It doesn't, can't really go anywhere. So the point that I started at is where I end at also. So I didn't like that because it's kind of tricky. And I'd rather have you guys get used to moving around, because that's really what we do, okay? So that was just for your information there, okay? Back and fix this. Okay, all right, moving on. Okay, if you could go ahead, get a graph or draw a graph, and we're going to go ahead and plot those 3 points and label it. You could just label it with the letters too. Okay. And then if go ahead and write these 2 rules, reflection rules. We're going to kind of play around with this a little bit. Okay. Got to change this too. Right, so we're going to go ahead and plot these 3 points. So negative 3, negative 2 is right here. Get my pen back. Negative 3, negative 2 is right there. Okay. Negative 5, negative 1 is right here. Right here. Oh my gosh. All right. And then negative 4, negative 5 is right here. Okay. Hopefully go. It's right. Oh my gosh. And we're going to go ahead and draw those in. This was point A. This was point B. Ooh, I did do this wrong. Hold on. Time out. We got discombobulated here. Sorry about that. Negative 3, negative 2 is right here. And negative 5, negative 1 is right there. I went opposite. And then negative 4, negative 5 is right here. Okay, there we go. Sorry. This is going to be A. This was B. And this is C. Okay. So what we're going to do is we're going to do this first rule. We're going to reflect it across the y-axis. So or the x-axis, sorry. So this is the x-axis, okay? Now what I have to do is I have 3 points. So each point is a different distance away from my line of reflection. So I've got to go each point separately, and I'm going to reflect it over the x-axis, okay? So I'm going to start with B since it's the closest. It's 1 away. It's 1 away from the x-axis, so I got to put it 1 on the other side. I'm going to call it B prime. Okay. We'll go to A. A is 2 away, so I got to go 2 to the other side of that line. So that's going to be A prime. Okay. Then C is actually from here. I'm 5 away, so I got to go 5 to the other side. I get to here, call that C prime, and then I could go ahead and draw my triangle. Okay. All right. So there's kind of the reflection across the x-axis for that triangle. Okay. Now, what I like to use the word or term flop. If you'll notice this blue triangle, I flop it over the x-axis to get to here. So I'm really kind of taking it and just twisting it and turning it over, kind of like a pancake, you know, with your spatula. You're making pancakes, now everybody's hungry, but I flopped it over to get it to the other point or wherever it lands, okay? All right. We're now going to take, and this gets a little messy here. I wish we could have done something a little different. And actually, let's do that. I'm going to change this up. Okay, I'm going to change this reflection to the y-axis. Okay, just so you can see it a little bit better. It gets messy with that other rule. So let's change this to the y-axis. Okay. So what I'm going to do now is I'm going to flop this new triangle, the A prime, B prime, C prime triangle, over the y-axis. So once again, keeping distance here, I'm going to flop it over it. Okay, so let's start with A since it's closest. It's 3 away. Okay, so I got to go 3 to the other side. That's going to be A, and we'll use now 2 prime symbols because this is the actual second movement. Okay, all right, we're going to take B, and it's 5 away, so I got to go 5 to the other side. We'll call that B. Oops. Prime away. Okay, and then we're going to go find C, and C is 4 away, so I got to come 4 to the other side of it. Okay, so it was 4 away here. I got to go 4 to the other side. We'll call that C prime prime, and then there's my new triangle. Okay, so you see the flopping. I hope you understand what I mean by that. Just kind of rotate it over. Okay. All right. So there you go. We're going to go down here to this one. If you guys go ahead and graph it, and it's the same triangle, but we're going to start with the y-axis, which I ended with, and then we're going to do a different reflection. That's x equals 1. So I'm going to keep it that way. This one will kind of be a little bit messy, kind of be on top of itself a little bit, but I'm going to keep it that way for this one. Okay, so if you go ahead and do this on your own, you can hit pause, go ahead and do it, and then you can hit play, and then I'll have this solution up. Okay. All right, so plotting the points, see if I can do this better than I did last time. Here and here. So this is A, B, and C. And I'm going to reflect it across the y-axis. And you guys don't have to draw the lines. You know, you'll see it. I will kind of caution you though, later on when we get to the chapter, we give you some worksheets, and the graphs are not printed very well. The x and y axis are not in bold, so they look like any other grid line. So I kind of get in the habit of just darkening in the specific line. So you can do it too. I'm not going to worry if you do or you don't. Now I'm going to reflect all these points across the y-axis. So once again, keeping points here. I'm taking A first. I am 3 away, so I got to go 3 to the other side. We'll call that A prime. Okay. I'll go with B. I'm 5 away, so just count squares. 1, 2, 3, 4, 5. So I got to go 5 to the other side. Okay, keeping distance. So that's B prime. C is 4 away, so I got to go 4 to the other side. Go ahead and draw your triangle. Okay, so hopefully that's pretty easy, and you can see I flopped it like a spatula with a pancake. Doing that. All right. Now we're going to where does x equal 1? So x equals 1 right here. Now remember, when it's this though, it's got to be a line. So remember, x equals 1 all along there. Okay. So now I'm going to reflect it back across this one. So keeping distance, I'll start with A again. It's 2 away, so I got to go 2 to the other side of this line, red line. So it ends up getting here, 1, 2. So there's A, and we'll call it prime prime because it's the second movement. B right here is now 4. That's 4 away, so I got to go 4 to the other side. There's B, prime prime. And then I got to go, C is 3 away, so I got to go 3 to the other side. C prime prime, and you could draw your triangle. Okay, so it kind of ends up getting close to where it started, but not quite. Okay, all right, so hopefully that was pretty good for you. Reflection is really not that hard. Just drawing a picture, probably need to make sure you get some graph paper. It's much easier to do with graph paper, okay? All right, just really quick, you guys don't, this is kind of a reiteration, these notes right here, reiteration of what we did earlier. And if you got these, just draw these 2 lines. It's not a graph, it's just 2 lines in a plane. So this is line K, this is line M, and then you got these 4 triangles, okay? And then the question is asking, which line did I reflect some of these across, okay? So if I went from 1 to 3, I'm reflecting it across the line equals M, okay? And then from 2 to 4, so just to making sure I keep the right direction, okay? It doesn't matter because you're reflecting across the same line, but just showing which way did you go. I reflected 2 to 4 across the line that equals K. Or you could just say line M and line K. It's not a big deal. Are they all ridge and motions? It appears that they keep the same shape and angles. Okay? All right. So I think that takes us to the end. Just, graph paper is really helpful. Draw your lines, go ahead and make sure you got the reflections, okay? All right. Have a good one. Make sure that you get your work done. If you have any questions, get a hold of me.